Good morning, everyone. So, what I want you guys to do is go ahead and pull out your pod notebooks. This video is going to be a little bit different. What I want you guys to actually do is I want you to go ahead and get this pod down in your book, and then I want you to pause the video. To get down this pod, remember, write down the whole problem, write down today's date. Yes, do draw the diagram, and actually try to solve this, okay? And then when you're ready to see the answer, press play. Okay, so go ahead and pause the video, get down this pod, and actually try to solve it. And when you're ready to see the answer, press play. All right, so hopefully you're ready to go ahead and tackle this problem, all right? Now, given this diagram, it is a trapezoid. More specifically, it's an isosceles trapezoid because the two legs here are equal. We have to show that DE is 2 meters. So we have to show that this is 2 meters. Now, showing means we have to do the algebraic process. And hopefully you did recognize that if you drop down another perpendicular, like I have here, from BC to AB, then you'll see. Oh, I do apologize. That's supposed to be a right angle. There we go. You'll see that what that actually does is it splits it into equal pieces. So basically, you'll have two congruent triangles here because this is 6 and this is 6 as well. These two lengths would be the same, and then so with these. Okay, making this segment here 12. Okay, and so then what you can do for part A to show, you really would actually have to show the algebraic process. That is just as simple as doing 16 minus 12, which equals 4, and then taking that and dividing by 2, which is 2 meters. And that will be the work to show that DE is equal to 2. Okay? Now to find the size of angle D, hopefully you recognize that to find that size that you are dealing with a right triangle, okay? You have your you have DE, which is there. You have EC, which is that perpendicular, and then you have DC, which represents your hypotenuse, okay? So knowing that DE is 2 and knowing that DC is 6, you basically have a right triangle where you know or where you're trying to find angle D. Now 2, if I label my size, 2 would be my adjacent and 6 would be my hypotenuse. And so I would use the trig function of, and you guessed it, cosine, to find angle D. And cosine is my adjacent side over my hypotenuse. And so to actually find the value of D, we would do cosine inverse of 2 over 6, or you could have put 1/3 to get our answer here, which is 70.5 degrees. All right, and hopefully you guys got that when you work this problem out. Okay, if you did get stuck, well, hopefully you're able to look at this and see, okay, this is where I made my errors and stuff like that. Okay. Now, what I want you to do is I want you to pull out your homework, and I want you to pull out a different color pen because we are going to check it. You had 3 problems that were all IB type of questions, and I wanted you to do those for homework. Now, we're about to go through all 3, and you guys should be correcting your work. All right. And this homework is actually going to go into page 21 of your notebooks. So it's not going to go into your 3-year binder. It's going to go into your spiral notebook. Let's go ahead and update your table of contents and add in page 21, and then glue in this worksheet into page 21. So for the first one, you had triangle ABC is isosceles. Isosceles basically means that they have 2 equal sides. And you were told that the 2 sides of AB and BC were the ones that were equal, and they were 10 centimeters long. And the angle that each side made an angle of 4 degrees with AC. You had to represent this information to a clear and labeled diagram, and as you can see from this picture, we have AB, BC that both have 10 centimeters, and those 2 respective sides make 40 degrees with side AC. Now from there, you can find the length of AC by dropping down a perpendicular that creates 90-degree angles here. Yes, you can do that with an isosceles triangle. Only with isosceles triangle can you go from one of the vertices, the vertex where the 2 equal sides meet, and drop down a perpendicular. Okay, what that actually does is splits your triangle into two congruent triangles where AP and PC are equal. So in order to find the length of AC, you would basically find the length of AP and you would double it. So to find AP, that is your adjacent side based off of the angle that you're given, and you have your hypotenuse. So you would use cosine of 40 degrees, and that would equal AP over 10, adjacent over hypotenuse. To solve this, we would multiply both sides by 10, so then that AP would equal 10 times the cosine of 40 degrees. And because we are looking for AC, which is twice the length of AP, that's where that 2 comes from. Okay, so 2 times AP, which was the cosine of 10 times the cosine of 40 degrees, and we get 15.3 centimeters once we round to 3 significant figures. Okay, so just to recap this particular part of this problem, AB can be drawn, which creates 90-degree angles and congruent triangles. So AP and PC were equal. That's why we multiplied it by 2. Now C asks you to find the perimeter of the triangle ABC. Well, at that point, we already know what AC is, which was about 15.3. It should still be sitting on our calculator. So then we take that amount, hence the dot, 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 the non-rounded answer, and then we add the 2 tens, which basically make 20. And then from there, then we round our final answer, which is 35.3 centimeters. Now, in your second problem, the diagonals of the rhombus are 10 centimeters and 5 centimeters. Remember when we went over rhombi, the diagonals were not of equal length. And so clearly one of the diagonals is going to be 10 centimeters long. So in my picture, I made BD 10 and the other diagonal of AC 5. And so you have to find the size of the larger angle of the rhombus. Now, also knowing your properties of diagonals of a rhombus, hence why I had you guys do that in that one homework assignment, which was the geometry review, is because the diagonals of a rhombus are 90 degrees. They intersect at a 90-degree angle, making right triangles. And on top of that, they bisect each other, okay? So that basically means that they get cut in half. That 10 gets cut into 5, and then that 5 gets cut into 2.5, as you can see in this triangle of BOA. O is nothing but that intersection where the diagonals hit to make those 90 degrees. So to find the measure of the larger angle, we would have to find this angle right here. This would create the larger angle. If you weren't sure, you could find the two angles and then recognize that A is the larger angle. And the diagonals do bisect the angle, so if we can figure out what this tiny little angle is, we would just double it to find the larger angle of the rhombus. So again, if we look at this triangle, 5 would be our opposite side, and 2.5 would be our adjacent side. And so we would be using tangent to find that tiny angle of OAB. So the tangent of angle OAB is equal to 5 over 2.5. And so then from there, remember whenever you're looking for an angle, you would end up doing the inverse of that trig function, and you basically go and type it into your calculator. That would give you the measure of angle OAB. Because we're looking for the measure of the larger angle, we just have to double it. So we just multiply it by 2. And at that point, that is when we round to 3 significant figures. And for the last example, I do believe I tried to correct this error. So please just double check. Make sure your picture in your trapezoid, it goes PQRS. If it didn't, then that was definitely 100% my bad, and I do apologize for that. When you are creating diagrams, you have to label them yourself. You're supposed to go clockwise or counterclockwise around the figure to label it, and if this did not say R right here, then that was my bad. I totally botched that one. So you should actually use this diagram here, because then from there it actually makes a little bit more sense on how you would go about figuring out the height. PS of the trapezium, aka the trapezoid, find the area of the trapezoid, and then find the size of angle SRQ. A lot easier. Okay? So to find the height of PS, you would drop a perpendicular down from Q to SR, creating a point, which is going to be T, that is perpendicular to SR. And so then from there, you'll be able to use Pythagorean Theorem to actually figure out the value of QT, which is the value of PS, the height of the trapezium. But just like before, from S to T, that is going to be 7 centimeters. So then from T to R, that would be 3 centimeters. So then to find your height, you would just use Pythagorean Theorem. As you can see over here, you have your hypotenuse. 3 is one of your legs. You're looking for another leg. And you'll end up getting that QT, which is PS, is 4 centimeters. And now that you have all the information that you need to find the area of your trapezoid, yes, I'm using the area of a trapezoid formula, which says that it is that is your height times base 1 plus base 2 all over 2. And using that formula instead of using, the area of the triangle, area of the rectangle, add them together, I have all my information. My height is 4, which I found in part A. Base 1 is 10. Base 2 is 7. And I just divide by 2. And that's how we get 34 centimeters squared. Yes, you can still get that same answer by finding the area of the rectangle and adding it to the area of the triangle. And then for the last one, which is to find the angle SRQ, we would use the fact that we're looking for this angle right in here. Okay, so this is going to be our theta. And since we know that TR is 3 and QR is 5, we can use cosine because this is our adjacent side and this is our hypotenuse. So we use cosine of SRQ is equal to 3 over 5. Take the inverse. And this really should be, I don't know why that's like that, but it should really be right here beside the cosine. And then the 3 significant figures, it will be 53.1 degrees. And as you can see, this note that you could have used sine or tangent because remember we did determine that the height of the trapezoid was 4. Okay, so you could have used sine or tangent to figure that out. You just would have had to set up the ratio a little bit differently. Okay, but those are the answers to your homework. I hope this video did help you to determine or to clarify any misconceptions you might have had on this topic up to this point. Now real quick, just to recap, remember to label the sides of your right triangle whenever you are trying to find the length of a side or the measure of an angle. Remember the opposite side is the side that's across, not touching theta. Adjacent is the side that's next to theta, that's not the hypotenuse. And the hypotenuse is always across from a 90-degree angle. SOHCAHTOA, sine, cosine, tangent, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent, to set up your trig ratios whenever you are looking for a side length or an angle. Don't forget about Pythagorean Theorem when you're trying to find the length of 2 sides, or when you have the length of 2 sides and you're looking for a third side. Okay, and also don't forget about how to find the gradient. Okay, remember that's where we started. Gradient is this formula y2 minus y1 over x2 minus x1, where x1, y1, and x2, y2 represent the points. Okay, don't forget about how to write expressions of expressions to represent your slope. Don't forget about that parallel lines have the same gradient and perpendiculars gradients are opposite reciprocals of each other. Their product should be -1. Don't forget to figure out where 2 lines intersect. You will want to set them equal to each other. And also there are 3 different ways to write a line. Gradient intercept of y equals mx plus c. Point slope, which is y minus y1 equals m x minus x1. And standard form, where everything is all on one side. Okay? Take the next few minutes, about 10 or so, to kind of go back over your notes. All right? And then get ready to take your quiz.